Hello everyone, welcome back to Quick Coding Bytes. Today we will be building the intuition for how computers count. At first, their counting system, known as binary, may seem very different than ours, but after a closer look, you will realize how similar the two are. Before we learn about the binary number system and how it works, let's first take a closer look at the decimal number system. The decimal number system is the number system that we use every day. The system has 10 symbols, 0 through 9, and we create all the larger numbers using a combination of those 9 numbers. The interesting part of our number system is when we go from a transition of 9 to the next number over. For example, let's take the example from 9 to 10. So if I'm going to write 9 down here, and then 10. Alright, so what's interesting about this? Well, the interesting thing is why do we go from 9, a 1-digit number, to 10, a 2-digit number? Well, because when we're at 9, we used up all of the possible symbols that we have in our number system. We used up all of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have a special symbol for 10. So what do? We take the counter of this place value. So 9 is the counter for this place value. And we reset it back to 0. And we increment the next place value's counter by 1. So we can imagine that this is 0 here. So we originally had 9 here. We don't have any more symbols left. So we reset that counter to 0 and we increment the next counter. Let's look at another example. Let's look at from 19 to 20. So we're at 19 here and then we transfer over to 20. Similar concept. We finished all the numbers or all the possible symbols that we have from 0 to 9. So we reset that counter back to 0 and we increment the next counter. This concept pretty much keeps going down throughout it. Now let's take an example of 99. So if I write 99 down, the next number after 99 is 100. Now why is that so? So here we used all the 10 possible symbols. So we reset that counter to 0. We increment this, but to increment that counter, again, we used up all the possible symbols. So we reset that counter back to 0, and we increment the next counter. So our entire number system is based like that. Now, sadly, computers can't understand these 10 symbols. The computers at the core only understand ones and zeros. The logical 1 is represented by electricity flowing through a wire, while the logical 0 is represented by the lack of electricity flowing through a wire. Think of it as flashlights. So if I were to move down here, think of it as flashlights. We have, if the flashlight is on, then that's a 1, and the flashlight's off, then it's a 0. So we only have two possible states. So that's why this number, or this system, is called the binary number system. The binary number system. Because binary means 2. There's only two possible symbols in this. So let's figure out how this counting works. Well, we can see the number 0 is all zeros. So remember that the leading zeros don't matter in a number. Even in the decimal number system, the leading zeros don't matter. So it starts 0, the binary equivalent is 0, 1, again, looks normal, binary equivalent's 1. But now let's look at 2. So I'm going to actually write down 0, the transition from 1 to 2. So we have 0, 1, and the next number is 1, 0. Let's figure out why this happened. It's because since we only have two numbers, by the time we put 1 here, we used up all the possible symbols we have. We only have 2. So we reset that counter back to 0 and we increment the next counter. It's as simple as that. Every time you use up all the possible symbols in a place value, you reset that to 0 and you increment the next place value. Let's look at an example from 3 to 4. So from 3 to 4 we have 0, 1, 1, and it transitions over to 1, 0, 0. Again, we used up all the possible symbols for this, so we reset it to 0. Now we're incrementing this, but to increment that, we already used up all the possible symbols. So we reset that to 0, and we increment the next counter to get 1, 0, 0. So this continues throughout, as you can see. So we looked at the transition from 0 to 1. We looked at a transition from 3 to 4. Look at the transition from 5 to 6. Let's do one more. From 5 to 6, we have 1, 0, 1, and it switches over to 1, 1, 0. Again, we used up all the possible symbols for this one, so we reset it to 0, and we increment the next position. That's it. That's how the binary number system works. So it's as simple as that. But another number system that programmers often deal with is called the hexadecimal system. It's a number system, so let me first write it down. It's called the hexadecimal number system. But the hex means 16, hex or 6. But hex means 6, decimal means 10. So 10 plus 6, 16. It's also short form is hex. So I mentioned earlier, it's a 16 symbol decimal system. It's a 16 symbol number system. And why would you use it? You use it because we know that computers use binary, zeros and ones, to represent all the numbers in the system. But it would be very tedious if you have a really, really long string of binary numbers to represent it by binary or decimal. So that's why we use the hexadecimal system. Because as you can see, we can represent 4 numbers in the or 4 digits of the binary number system in one hexadecimal number. The reason for this is because the hexadecimal system has 16 symbols. The symbols start same as the decimal number system, up to 9, but then for the last 6 symbols, it uses the letters A through F. So let's look at the transition a little bit from F to the next number. So let's play a game here. What do you think the next number is going to be? Or the next hexadecimal number is going to be? Well, let's look at it. Let's use the same principles we saw in the decimal number system and the binary number system. So we're looking at the transition from 15 to 16. This is a decimal number. And let's look at the hex. So we have F. Well, F can also be 0. So if we were to increment F by 1, well, there's no G. There's only 16 symbols. So what do? You'll reset the counter to 0, and you increment the next one. Now, let's say we go all the way to 31, because you can just keep incrementing this. So let's say you got to, let's say you got to 31 as 1F. What do you think the next one's going to be? So let's look at 32. Well, we have to reset this counter because we don't have any more symbols, so we bring that to 0. And what do you think this number is going to be? Well, you increment it by 1, so you get 2, 0. So hopefully this gives you a new perspective on how different number systems work and how you can use different systems to represent the same number. Thank you for watching this video. Stay tuned for more.